to our last method, which is the Gaussian elimination method and Gauss-Jordan elimination method. Now what exactly it is, we'll find it out. Okay. Now we're going to consider the same example. Okay, no, it's a different example. We are taking example this. Now it is also a 3x3 system, 3 equations and 3 unknowns. Now what I have done out here, when we are actually doing Gaussian elimination, what we are going to do, I've explained this thing earlier, that this is my augmented line, right? So this side of the part is my augmented matrix. This is the coefficient side, and this is basically the constant sign, which is separated by an augmented line. Okay, so these are two different sides. This is the coefficient side. Coefficient is 6, minus 3, 1, 1, minus 7, 1, 2, 1 and minus 8. Okay, and the other separated part, these are basically my constant, 11, 10 and minus 15. Now when we are doing Gaussian elimination method, what we are going to do is that we're going to convert this part into, we're going to reduce it into an identity matrix, not exactly into identity matrix, but the rule is for Gaussian elimination is that all the pivot positions should be a non-zero element. Okay, should be a non-zero element. These are my pivot positions, or you can say the diagonal elements. The pivot position should be a non-zero number. Okay, and all the entries below the pivot position should be equal to 0. This is basically the main condition for Gaussian elimination. Now out here, if let's say these are these three, these diagonal positions are my, when I myself am converting it into Gaussian elimination form or Gaussian form, what I'm going to do is that this principal axis this will be my pivot positions. These three will be this diagonal line, or what we call it the principal axis line. Okay, this will be my pivot positions, 6, minus 7 and minus 8. These three are my pivot positions, and all the elements below pivot positions should be equal to 0. Okay, now we know that pivot position should be a non-zero number. Okay, so you can just, when we are doing manual calculations, what we prefer converting these pivot elements into one, because it is easy to calculate further, to find out the multiples and to subtract, to add and cancel the values. Okay, so it is easy to convert it into one, but the main condition says that the pivot position should be a non-zero number. Okay, and since we converted into one is a non-zero number. Okay, so what I'm going to do out here, I'm going to make this is my first pivot position. Okay, this is my first pivot position. I will be making it 1. I will convert this 6 into 1, so that it is easy for me it will help me and will be easy with my further calculations. Okay, when I just divided by 6, this is 1, minus 1 by 2, 1 by 6 and 11 by 6, and I'm going to divide the whole complete row by 1 by 6. Right, now I need to make, it says that pivot position is 1 and the entries below pivot position should be 0. Now this number should be 0, this number should be 0, so we need to apply some operations in order to make it 0. Right, now first of all, I have in order to make this 0, that is this one to 0, what I'm going to do is that operations are applied on R2. So R2 plus minus of R1, that is plus minus, we're going to multiply this row by minus 1 and we're going to add it into it, so that we'll get a desired answer. Let's say 1 plus into minus 1, that is equals to 0. Then minus 7 plus, now this minus R1, that is minus half. So already it was minus, so minus into minus is plus. So minus 7 plus 1 by 2 is equals to minus 13 by 2. Then 1 R2, the operations since are applied on R2, so 1 plus minus 1 by 6, which gives you is equals to plus into minus minus 1 minus 1 by 6 is equals to 5 by 6. Okay, then this part 10 plus minus of 11 by 6 is equals to 49 divided by 6. So this is what I got after simplifying it. Okay, after just writing it down. Next I need to make this position, this number equals to 0, since it said that the pivot position should be a non-zero number and all the entries below should be equal to 0. Now okay, so the operations that needs to be done are to make this number 0 is R3 plus minus of 2 times of R1. Okay, so the operations are applied on R3. And now here you can see that what I have done is 2 plus minus 2 times into 1 is equals to 2 minus 2 equals to 0. Then 1 plus minus 2 as it is into minus 1 by 2, minus 1 by 2 came from R1 here, is equals to 1 plus 1, which is equals to 2. Then minus 8 plus minus 2 into 1 by 6 here equals to minus 8 minus 1 by 3, which is equals to minus 25 upon 3. Then lastly minus 15 plus bracket minus 2 multiplied by 11 by 6. When I simplify it, this is what I get, minus 56 upon 3. Okay, so there you get it. Alright, now for my next pivot position, I say we will move towards this side and we say that this is the next pivot position. Okay, what I'm going to do is that I'm going to convert it into 1 so that it's easy for me to calculate the values, right? Here, when I just divide it by, multiply the second row by minus 2 by 13, this is what the final thing I got. Now it says that all the entries below pivot position should be equal to 0. Now this is, if this is my pivot position, okay, it's 0 out here. I've just misprinted it. All the numbers below the pivot position should be equals to 0. Now this number should be equals to 0. Now the operations required is R3 minus 2 of R2. Okay, this was my okay, yeah, alright. Okay, the first thing was minus 25, this becomes 0. Minus 25 by 3 minus 2 times into of R2, that is minus 5 by 39, right, which is equals to minus 105 upon 3. Now I have calculated and simplified it. Then minus 56 upon 3 minus 2 times minus 49 upon 39, this thing. Okay, now when I simplify it, this is what I get. Now I just substitute this value. Now out here, students, this is basically 0. I have just misprinted it and written it too. I'm sorry about that. Okay, now lastly, this is basically my pivot position. Now if this is my pivot position, I'm going to convert this element into 1. Okay, when I just convert this into 1, this will becomes 1, and if I multiply it, this part will becomes 2. Okay, here you can see the final answers. Out here the pivot elements are 1 and all the entries below pivot positions are equals to 0. Now since this is my pivot position, okay, we move towards the right side. Since this is my pivot position and there are no elements underneath this element, so this is gonna stay like as it is. If you want, you can just if you don't want it to write it down or convert it into 1, it's okay. You can proceed like this. Okay, so there is no as such thing that you need to write down, you need to convert it into 1. It's like it's easy. It's easy to convert it into 1 and then solve it further. Or if you think that if you're good at it and you can manage it well, it's completely up to you. Okay, now here this is basically the called Gaussian elimination, where pivot positions are 1, all the pivot elements are 1, and all the entries underneath the pivot positions are 0. Okay, now what we are going to do, we need to find a value for x and y. Now we will be using backward substitutions for finding values for x, y and z. Now z is equals to 2. Now how I said that z is equals to 2? See, this position defines x, y and z. Okay, so z augmented equals to 2. Augmented line basically separate these two matrices. This was for my constant, and all the values written after equal to are written here. So this, if this is my x, y and z, so z is equals to 2. Okay, y minus 5 upon 39, z equals to minus 49 by 39. Then x minus 1 by 2y plus 1 by 6z is equals to 11 by 6. What I have done out here is that I've just write it down all the results, the equations that I got after the Gaussian elimination. These are my results. Okay, now this is my equation A and this is my equation B. Okay, now what I'm going to do is that I'm going to substitute value of z in equation A. When I did that, okay, I will be getting value for y, that is y equals to minus 1. Okay, now what I'm going to do is that I'm going to substitute value of y and z in equation B. Now this was initially my equation B. When I substitute value for x, for y and z, this is what I get, and finally I will be getting value for x, which is equals to 1. So the solution set is 1, minus 1 and 2. Okay, now for Gauss-Jordan elimination, you all know that this was the point where we declare it as, that this is my Gaussian elimination. Gauss-Jordan is that you need to convert this part of the matrix into an identity matrix, completely into an identity matrix, which is also as a reduced row echelon form. Okay, where you just convert this part of the matrix into an identity, and this will remain as it is. Okay, we'll just perform the operations on it and find out what will be the answers. Okay, in order to convert this part into identity matrix, what I'm going to do here is, see, this is 1, the element before 1 is 0. Now above should also be equals to 0. So R1 plus 1 by 2 of R2. Here you get 0. And okay, so the next element will be R1 1 by 6 plus 1 by 2 into minus 5 by 39. So this is what you get out here, 4 by 39. Then for 11 by 6 plus 1 by 2 into minus 49 by 36. And this is what the final answer you'll get. Okay, out here, see, 4 by 39, 47 by 39. Then the operation required now, since these two clear, we need to convert this part into identity part. Now these two numbers should also be equal to 0. First of all, I will convert this number into 0, that is minus 5 by 39 into 0. What is the operation required? R2 plus 5 by 39 of R3. Okay, if you do this, it is equals to 0. And for this side, minus 49 by 39 plus 5 by 39 into 2. See, R3 is equals to 2. Just solve it. The result we get is minus 1. Then, okay, then we need to convert this number into 1. So R1 plus into minus of 4 by 39 of R3. What will happen is, 4 by 39 plus minus 4 by 39 into 1, which is equals to now 0. And this part will be 47 upon 38 plus minus 4 by 39 into 2 is equals to 47 by 39 minus 8 upon 39. So when you solve it, you get 39 by 39, which is equals to 1. So this is what you get finally. Okay, now as you can see, when we wanted to find out value for x, y and z, earlier we say that this is my z point. Okay, so z was equals to 2, y equals to minus 1 and x equals to 1. Alright, so this is how Gauss-Jordan elimination is done. The solution set is 1, minus 1 and 2. I hope that you have understood about matrices, that what are matrices from the beginning till solving of linear equations, system of linear equations. I hope it was helpful to you all, and I will see you soon with my next lecture. Thank you so much.